All right, now we're back, and yeah, what do we want to do now? And I think you have most of the basics down. You know the script, you know the functions and how to program them, how to make sure you got the output. If you want multiple outputs, make sure you define your inputs. Uh, if you have ever took programming, I think probably all of you do. Um, you should know flow control in programming. But just in case you don't, let me use this video to talk about flow control in Matlab so that you gonna, uh, you know about it. And if not, just, really, those things should not be the focus of this class, but I'm gonna do it anyway. So, what I'm gonna do is I'm gonna use a function as an example to explain two flow control. One is the loop. So basically, you just looping through, repeating one thing multiple times. We're gonna talk about the for loop in Matlab. The other thing is I'm gonna talk about the if loop. Not if loop. Yeah, it's not a loop. It's the if statement. So basically, if something's true, then do this. If not true, do whatever. If you get those two things understood, you should be fine with everything that's needed for this class. Of course, there's always a better programmer out there somewhere. But we're gonna just cover basics. So, what we're gonna do is, let me bring a paint. Yeah, because it's kind of boring to hear me talking all the time. And yeah, I'm using a mouse, so my painting will be bad. So what this function does is that I'm gonna basically generate a distribution, normal distribution. I'm gonna generate a whole bunch of samples. Okay. Then I'm gonna let the user input the mean and standard deviation of my distribution. Then how many samples we're gonna generate, like n. Then I'm gonna find out how many of the sample I actually generated is greater than mean plus standard deviation. And you're like, yeah, we kind of know it's normal. Then there's a table for that, but depending on the number you put in, yeah, it might be a surprise. But let's just do that. So the first one is like we're gonna do a function. Result equals to, we'll just say this is a test one. Okay, yeah, we'll just call it test one for no reason. So we'll have the mu. You have to give me that, and std you have to give me that. Yeah, and let's not do std because std is actually a function of Matlab itself. Let's just do come on, mu and sigma, and then the n. Okay, that's our standard. How many of them are gonna be there? I'm gonna say, okay, this function will find out how many generated sample are greater than mu plus sigma. Okay. Yep. So first we need to generate the sample, right? So just put it in temp, a temporary thing. I like to use temp in functions simply because that will remind me it won't exist after my function is run. So you got a norm R&D of mu, okay, sigma, and we got our one, okay, something like that. Okay, we got that part. Oh, come on. We got that part. Then we're gonna do a loop. So because what I need to do is I need to now the temp will have n numbers in it. It's a vector. It's a 1 by n vector. So now I need to compare each one of those numbers inside temp and figure out if they are greater than mu plus sigma or they're smaller. If they're greater than that, I start to count them. So this is a classic counting problem, so I'm just gonna do a counter. That's another variable equal to, I see right now it's 0, so there's nothing have been compared yet. Then I'm gonna loop through 4. Okay, you need a looping indicator. For this, I typically like to use II. You ask me why don't I just use I? Because I actually in Matlab is the imaginary unit number I, and I always use II or JJ. Next time I do KK. Because I know if it repeats, it's a counter. It just keep repeating. So then I'm gonna go from 1 I, then colon to apparently to n, right? But yeah, I can either do n here because I know there's n numbers in there, or I can just do length, which is inside the Matlab function to tell you the length of a vector of temp. Okay, so as I do enter, Matlab automatically first it did two things. Firstly, it kind of remind me you need an end for 4. Okay, so I'll do that at the end. Another thing is that it actually, indented my line here so that it's within the loop. So in here, I'm gonna say, okay, if just like normal English, if temp, because I gonna keep looping from 1, 2, 3 all the way to n, so I'm gonna just use II. If temp II is greater than mu plus sigma, okay, I'm gonna let counter equals to counter plus 1. If you're like in C++, you just say counter plus plus. But, Matlab, you have to do this. Then, apparently the if did the same thing. It said, okay, well, if you have if, you need an end. And it indented this so that we know this is under if. So you just do that, and then you'd say, okay. So then you're going to say, okay, well, what if it's not? If not, this will not get executed, so nothing will happen. Okay, end. Now it kind of matches that if. Then I'm going to do another end for the 4, which matches automatically. So it will actually give you the counter. So basically this for loop will go through all the temp, make a judgment for each one of them. 1, 2, 3, because I keep changing. If it's greater, then it will add to the counter. By then, the counter should be all set. So all I need to do is just res equals to counter, because I want to output it, right? That's it. Okay, let's give it a shot. Save. And then it's like test 1. Okay, I'm gonna go good with that. CLC, and then I'm gonna test 1, and then we're gonna try to input our stuff. The mu, let's say 7, maybe a sigma. What is that? Like 3, and n. Yeah, let's generate 100 samples and see what happens. Okay, well, this is not that impressive, but what it does is that it actually counted out of my 100 samples, it has 17 that's greater than 7 plus 3, which is 10. You're like, okay, really? I would not know, right? Because once it generated things, it goes into temp. Then I counted all temp. And then output doesn't have temp. So whatever I generated within this already disappeared. All I got is 17. You're like, oh, that's very helpful. Yeah, if you want to like really check if this thing really works, so maybe you need to output temp too. So let's just change it. We'll just like restart just small n equals counter, okay? And then we'll just restart x, okay, equals to temp. Yeah, this way we actually can prove that we're actually right. Let's save it. Let's run it again. But remember now we want to we don't do s. We want to kind of assign to something, because let's assign to hold on. Let me clear everything, okay, just so that we're on the same page. Let's redo this and then let's assign to a, okay. Done. You got a as the structure, which is you're like, hold on a second, it's 17 here and it's 14 here. Yeah, because it's randomly generated. So you're like, oh no, yeah, how do I know this is right? Okay, you can look at x. So you can do, in fact, you can just do this. A dot x, and then you just, okay, here's your 100 generated x, and you can count whoever is over 10, then see if there's 14 of them. Yeah, but they're all random. Like here's 1, here's 1. Yeah, it's kind of hard, right? You don't want to do that. So what you can do is that you can do actually sort a, which will sort it. Yeah. So you just do sort. It's actually rank order a dot x, right? That's what our numbers. Okay. So you can see, okay, it actually sorted everything from small all the way to big. How many of them are greater than 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which is the same number as a dot n, which is 14. Okay, that's it. Yeah, if you want to like really do it, you find out. Okay, let's generate 10,000 of them. Okay. Then you have about 1500, which is about roughly the same ratio, which we know by design it is true. All right, that's it for this time. We'll talk to you later.